Hello everyone, let's start with a little reminder. I told you about this project that I am working on right now. A 2 degrees of freedom pen plotter robot. As I said, this project is to learn more about hardware development, electrical engineering, and mechanical engineering. For the moment, it's been quite fun to develop. I also know that I am lacking a lot of knowledge, but that's what is fun about it, getting out of your comfort zone to learn more new things in general. So, this has been week number 2. It's Thursday night right now in glorious Budapest, and this is what I worked on last week. So first of all, electrical engineering. This is where I lack the most knowledge, I think. Thanks to the help of a friend and coworker, maybe he will recognize himself if he is watching this. I had a little intro of the couple of things I might need for this project. What kind of motors I could use, how to use them, a little moment back to the basics with amperage and voltage, induction, capacitors, and all that kind of good stuff. So I knew I needed to first just go around and gather some information about the different stuff that I would need. Starting with stepper motors. So I do have a few in my arsenal, so that's going to be nice for first prototyping. And I had to learn more about how they work. And it is not as simple as I thought it was going to be. So classic DC motors or brushless motors, they just have to receive voltage in order to just start spinning, right? It's not the same at all with stepper motors. It is quite a little bit more difficult with different phases and essentially a rotation segmentation on the main shaft that is essentially a big magnet. And this is why stepper motors are called stepper motors. The division of the actual magnet itself in combination with the different phases being turning on and off, this is what gives it the name stepper motor. And this is also why it is quite detailed, if I can say. Not detailed, precise. There you go. So yeah, got to read quite a lot about how stepper motors work, about the ones that I have right now. And so to go along with those, you usually also use drivers, motor drivers. And so for simple desktop, well, if I call them desktop stepper motors, the usual driver that you're going to use are those red ones right there. Pretty tiny. But essentially, what those do, they take in a particular signal coming from your microcontroller, and they essentially are the one who are going to decide what amount of voltage and when to send to the actual motor to make it rotate a particular amount of degrees, let's say. So this is a very big simplification, but this is what I understood so far, with also micro-stepping and that kind of stuff. And yeah, this could be like a series of video all of its own, but that was pretty interesting so far. So yeah, stepper motors, drivers. Oh, and I also got to go back on some old courses of mine about voltage and amperage. So it turns out 3.5 volts or 5 volts that are usually out of those little modules, here it's an ESP32 that can only do 3.3 volts, that amount of voltage will not be enough to drive a stepper motor like this. As I told you just earlier, those drivers right there can essentially outsource the power from somewhere else and decide when and how to put it into the stepper motor. And so this is where this is going to be useful. So I don't have it with me right now, but this is essentially an AC to DC power supply, and this is what is going to give the juice to our stepper motors. And so yeah, I got also to learn about these things, how they work, and also how to not kill myself and not do anything stupid. I did play with those before on a previous school project, but I just ordered a new one, and this is what will allow us to essentially have our motors up and running, let's say. And so you also just saw right there, so we did talk about the 12 volt adapter. This is our juice, this is a driver, and this would go to an Arduino that is like stated right there. But what is this little thing right there? Something that I never played with before were capacitors. And I had to, because like I saw a bunch of these on different schematics of projects like these, and I was like, why would those be important? So what is a capacitor? I could make the mistake of saying it's just a tiny little battery, but maybe I shouldn't do that. The electrical engineering community is going to fall on my face if I say that. But I also had to educate myself on this part, and this showed me how much I also don't know about electrical engineering and how much I need to keep educating myself. By the way, the engineering mindset, if you are into electrical engineering or want to get into it, this was an amazing YouTube channel so far. Like, it helped me quite a lot to decompose what I wanted to do with this project. And so there is this big video all about capacitors and why it would be important for this project. To make a long story short, why would that be important? So essentially, the capacitor would be in between the juice that would go into my driver aka the PSU, into the red little thing right there. And since that PSU is AC to DC, AC being alternative current to direct current, that can introduce noise in the mechanism. And the capacitor allows you essentially to denoise the signal going into the driver. This is oversimplified, very oversimplified. And maybe in like a couple of months I will say like this is total bullshit, but this is how I understood it so far. So I did order my little 100 microfarads capacitors, they are right there, and this will allow us to be as safe as possible, or at least I hope. I do not want one to blow up in my face, but even if it does, I should be okay. So concerning the news on the electrical engineering path, that's all. Next, well, we did talk about it a little bit, but parts gathering. This is a little picture right there. So yeah, I almost have everything to start prototyping hardware-wise. I did talk about the different drivers. I talked about the stepper motors. I did also get some hardware because like, you know, little bolts and fasteners to be able to plug things around. And I already had, as I said in the previous video, a couple of things for me to play with, like my trusty old ESP32 right there, breadboards, dev cables, and that kind of stuff. And also, so I am still working on it because we didn't make that in the previous video. Damn, this is incomprehensible. But yeah, I'm trying right now to also make the actual schematics of the actual robot. The thing that I was interested in also is that since I am using two motors, how would I be able to plug two drivers to one ESP32? And would that even work? And so I fell on this article that shows how to run 3 different motors with 3 different drivers on one single ESP32 dev module. And so I'm going to get a lot of inspiration from that as well, that's for sure. But yeah, parts gathering and planning the electrical schematics, this is what's new on that part. Now, on the previous video, I did talk about dev environments, specifically platform.io. And so nothing crazy at the moment. I just wanted to see if that could work for my particular project, and it does wonderfully. So this is just a little test script to like move at different angles, that little servo motor right there. I was impressed how seamless that was. Like platform.io, there is this website to download the extension on VS Code. I installed it and everything is right there. You have the different libraries, dependencies that is already taken care of. It creates a proper architecture structure for your project with directly git ignore. And apparently the platform.io.ini would be, I'm sorry in advance for that, is a little bit like your package.json in Node.js. But yeah, this right there, this was pretty nice to use so far, and I like it. I actually cannot wait to like properly start to develop this robot on there. So yeah. Oh, and it also reminded me of developing for an ESP32 because it's something I did in the past, and yeah, just a little bit of good old nostalgia right there. So yeah, on the software side, this is what's new. Next, modeling. So as I said in the last video, I would love this project to be as 3D printable as possible, and I already went through a couple of iterations for the actual arms themselves. So these are 3 different iterations for one of the joints of the actual robot, but I need to print way more than that. Let me show you. Do I have a better picture somewhere? Yes, I do, right there. So yeah, you can see in the middle, like stuck on the actual stepper motor, a couple of arms, and yeah, little studs right there to block the actual bearings. Oh, I didn't even talk about the bearings and the parts gathering, but whatever. 3D printing wise and modeling wise, like this has been going in the background. I think this is what I like doing the most right now, but also I've been running into an issue. So I am using Fusion 360 just to try. At school, we used a lot of SolidWorks, which I liked a lot, but Fusion 360 has a personal use license that seems to be pretty nice. But right now, I'm already starting to feel the limitations. So maybe we should look into something else already right now. But let's not talk in advance. For the moment, I am playing around with Fusion 360. It is pretty nice. And I've been able so far to create somewhat okay parts for my application. So these tests mostly were to get used to different tolerances because I'm printing with particular materials and my printer has a certain amount of details it can produce. So this is also to, yeah, just play around with the tolerances and see where this project could go and what do I need to be careful about. Careful about. And yeah, I think I'm developing a quite okay workflow between Fusion, my 3D printer, and the project. The thing I'm struggling with right now is also a little bit of organization. I don't know how to keep myself let's say, clean in my different iterations, but I'm trying my best and I already feel that I'm doing quite some progress right now, which always feels great. So yeah, for this week, that is it. Honestly, it is quite fun. I'm learning a lot of things. The thing that bothers me the most is the waiting time of developing for hardware. I think I have a short that will be released on that soon, but yeah, like it feels that right now, like I haven't done any major errors, but like it feels that you are going to pay either financially or time-wise when you make a mistake developing for hardware. Let's say like I have a blown up capacitors and like it's been my 5th one of this packet. All of a sudden, I don't have any more. So I just have to reorder, re-wait, and like trying to find some stuff to work on in the meantime. That I am not really excited about. But in the meantime, the thing that I like though, I am slowly building my hardware arsenal. For example, on this image right there is this multimeter. I didn't have one. I just realized that I didn't have a multimeter, which is pretty important when it comes to just making stuff, right? So that's pretty nice. Okay, I think I am done ranting right now. If this is a project that is interesting to you, do not hesitate to like, subscribe, and share that to different people. That is it for me. Cannot wait to make some more progress. And I talk to you guys soon on the internet. Bye bye, everyone.